sparingly water-soluble salts. Question number 1. The solubility of salt XA solid in water is 2.01 milligrams per cubic decimeter at 25 degrees Celsius. Calculate the solubility product KSP of XA solid at 25 degrees Celsius. Solid XA is a sparingly water-soluble salt. That means when XA is added to water, very small quantity will be dissolved. At 25 degrees Celsius, when this solid XA is in equilibrium with its aqueous ions, the solubility of XA is 2.01 milligrams per cubic decimeter. This means 2.01 milligrams of this salt XA will be dissolved in 1 cubic decimeter solution. Solubilities of these two cations are required to calculate the solubility product of the salt XA. To that, we need to convert this given solubility into moles per cubic decimeter unit. There's an easy way to convert this unit. First, this milligram can be converted to grams per cubic decimeter. Then, grams can be converted to moles per cubic decimeter. Now we will do the calculation. Solubility of XA 2.01 milligrams per cubic decimeter. First we will convert milligrams into grams. Therefore we can write 2.01 divided by 1000 or 2.01 times 10 to the power negative 3 grams per cubic decimeter. Here we have converted the mass milligrams into grams. This indicates 2.01 times 10 to the power negative 3 grams of XA is dissolved in 1 cubic decimeter solution. Now, this gram should be converted to the moles. There's an equation. Number of moles is mass divided by molecular mass. Therefore, this mass should be divided by the molecular mass of XA. 2.01 times 10 to the power negative 3 grams divided by the molecular mass 150 grams per mole. Grams and grams is cancelled out. This gives the unit of moles. So it's moles per cubic decimeter. Therefore, solubility of XA is 1.34 times 10 to the negative 5th moles per cubic decimeter. This is the equilibrium when solid XA is in equilibrium with its ions. Now we have calculated the solubility of the salt XA. Therefore, the solubility of X plus ions is also 1.34 times 10 to the negative 5th, and the solubility of A minus also 1.34 times 10 to the power negative 5th moles per cubic decimeter. Next we will write the KSP expression. KSP equals X plus ion concentration times equals A minus ion concentration. X plus ion concentration is 1.34 times 10 to the negative 5th moles per cubic decimeter times concentration of A minus is also the same because the stoichiometry is 1:1. Therefore, it's 1.34 times 10 to the negative 5th moles per cubic decimeter. of Xa equals 1.79 times 10 to the negative 10th mol second dm negative 6th. Question number 2. A completely water-soluble salt NaA is added slowly to a 1 cubic decimeter aqueous solution containing 0.1 moles of aqueous X plus ions and 0.1 moles of aqueous Y plus ions. 0.1 moles of aqueous X plus ions and 0.1 moles of aqueous Y plus ions are present in 1 cubic decimeter solution. Number of moles of these two cations are the same as their concentration because the volume of the solution is 1 cubic decimeter. Therefore, we can write the concentration of the two cations. 0.1 moles of aqueous X plus ions and 0.1 moles of aqueous Y plus ions are present in 1 cubic decimeter solution. X plus ion concentration 0.1 moles per cubic decimeter. Y plus ion concentration also 0.1 moles per cubic decimeter. NaA is completely water-soluble salt. When this salt is added to the solution, it completely dissociates into its ions, Na plus ion and A minus ion. Initially, we learned that Xa and Ya are sparingly soluble salts. A minus ions are also present with these two cations. Therefore, there is a possibility of forming these two precipitates in this beaker. When the ionic product is greater than Ksp, there is a possibility of forming these two precipitates in this beaker. Now we will move to the part 1 of question number 2. Predict which salt precipitates first. This solution has to be saturated before the precipitation forms. In saturated solutions, ionic product equals Ksp. Here we have the two Ksp expressions for these two salts. The concentration of X plus ions and ions are the same. They have the same value. Therefore, the salt which required less A minus concentration precipitates first. Now we will move to the calculation. First, we will calculate the concentration of A minus ions requires to precipitate Xa solid. Solubility of aqueous X plus ions is 0.1 moles per cubic decimeter. And we need to calculate the concentration of A minus ions. For that, we can use the Ksp expression. Ksp equals concentration of X plus ions times concentration of A minus ions. We have calculated the Ksp value of Xa during the question number 1. The answer is 1.79 times 10 to the negative 10th equals concentration of X plus ions 0.1 moles per cubic decimeter times concentration of A minus ions. Concentration of A minus ions equals 1.79 times 10 to the negative 9th moles per cubic decimeter. Therefore, concentration of A minus ions requires to precipitate Xa is 1.79 times 10 to the negative 9th moles per cubic decimeter. Next, we will calculate the concentration of A minus ions requires to precipitate Ya. Solubility of aqueous Y plus ions is 0.1 moles per cubic decimeter, and we need to find the concentration of A minus ions. We will write the Ksp expression. Ksp equals Y plus ion concentration times A minus ion concentration. Substitute values for this expression. Ksp of Ya is given in the question 1.8 times 10 to the negative 7th equals concentration of Y plus is 0.1 moles per cubic decimeter times concentration of A minus ions. A minus ion concentration equals 1.8 times 10 to the negative 6th moles per cubic decimeter. Therefore, concentration of A minus ions requires to precipitate Ya is 1.8 times 10 to the negative 6th moles per cubic decimeter. Now, compare the two values. 1.79 times 10 to the negative 9th is less than 1.8 times 10 to the negative 6th. Therefore, less concentration of A minus ions is required to precipitate Xa. That means Xa precipitates first. Question number 2, part 2. Calculate the cation concentration that remains in solution of the salt which precipitated first when the second salt begins to precipitate. When the second salt begins to precipitate, concentration of Y plus ions is 0.1 moles per cubic decimeter, but the concentration of X plus ions is unknown. When Ksp equals ionic product, the second salt Ya begins to precipitate. At this time, Y plus ion concentration is 0.1 moles per cubic decimeter and A minus ion concentration is 1.8 times 10 to the negative 6th moles per cubic decimeter. We calculated this value during the previous question. Therefore, at this time, A minus ion concentration is 1.8 times 10 to the negative 6th moles per cubic decimeter. At this time, A minus concentration is 1.8 times 10 to the negative 6th moles per cubic decimeter, and we need to calculate the concentration of X plus ions. We can get the answer using the Ksp expression of Xa. Ksp of Xa is 1.79 times 10 to the negative 10th equals X plus ion concentration times A minus ion concentration is 1.8 times 10 to the negative 6th. X plus ion concentration is 9.9 times 10 to the negative 5th moles per cubic decimeter. Therefore, concentration of X plus ions that remains in the solution when the second salt begins to precipitate is 9.9 times 10 to the negative fifth moles per cubic decimeter.